starting off quadratics with quadratic functions with our graphing from standard form. We're going to look at some how to graph and some graphing attributes that we can pull out. All right, here is our quadratic function. This is what we call our parent function, y equals x squared. This is also called a parabola. That's what kind of shape this is. You might want to know that if you did not. All right, our standard form we have is f of x equals ax squared plus bx plus c. And our parent function, just like we just had up there, is f of x or y equals x squared. And so that's just going to be our standard quadratic function on our graph that hasn't been moved, hasn't been changed in any form or fashion. All right, our standard form, and here's some attributes that we can pull out from our standard form. Maybe. Okay, our domain for these functions are going to be all real numbers, always all real numbers. And our range, we're going to write, if it opens up, so it looks like this, then our range is going to look like bracket, our y from our vertex, comma, infinity, parentheses. Remember our brackets and parentheses for domain and range. If not, maybe we should review that as well. If it opens down, it looks like this, so then it's going to be going from negative infinity, so open bracket negative infinity, to y of the vertex. That should be negative infinity. Our x-intercept is where y equals 0, and we could have none, 1, or 2. So it might not hit our x-axis at all. It could be way above it. It could be way below it. It could be right on it, so our vertex is our x-intercept, or it could go through the x-axis, and then we would have 2. Our y-intercept is where x is 0. Remember, that's where it crosses the y-axis. And so that's going to be at 0, comma, c. That's c from our standard form equation. So that also to note, if it's plus c, then it's going to be a positive c for our our y-intercept. And if it's a minus c, then it's going to be a negative. C is from our standard form. And there's always going to be a y-intercept. Because our domain is all real numbers, it's always going to, at some point, hit that y-axis. One time. Always, only once. Our vertex is at negative b over 2a. So negative b, what do I mean by that? I mean the opposite of whatever b is. So if it's up there in our standard form, if it is positive b, then it's going to come down here to our vertex and be negative b. If it is a negative b, then it's come down here and it's going to be a positive b. So it's going to be the opposite of b over 2 times whatever a is. And then our y of that is, we're going to take whatever we get for x, we're going to plug it into that, into our equation, solve for it to get y. Plug it in wherever we see x. So our maximum and minimums. If that a number is a positive number, that means it opens up, and we're going to have a minimum down at the bottom of our graph. If that a is a negative, then that means it opens down, and we're going to have a maximum. And then our axis of symmetry is the same as it's been for all these other graphs. It's going to be the x value from the vertex. So it's going to be x equals that x value, whatever we come up with that. All right. Another way of finding all of this information is to graph it. We can graph it by hand, or we can graph it in our calculators. We can just graph it, and then we can find all of these things from the actual picture of the graph. And the how to graph in the calculators we have is on your notes. There's also, I'm going to put a link to Desmos. If you don't have that calculator at home, you can always graph it on a website. All right, the next video is going to show you the examples for this information.